Resistant spot welds are formed by heating a spot of metal electrically while applying pressure in the form of squeeze force. The heat brings the metal to a plastic state, and the pressure pushes the heated metal from the two surfaces together, creating a weld nugget that joins the two pieces. The heat for this weld is created from the electrical resistance of the workpiece, hence the name resistant spot welding. Here is how the process works. The parts to be joined are placed together. Where the two parts meet is called the faying surface. This is where the weld will be formed. The two copper electrodes of the weld gun are brought together on either side of the joined parts. They press together, squeezing the parts between them with great force. While the parts are held together, a low voltage, high amperage electric current is passed between the electrodes. As this current passes through the pieces to be joined, it encounters resistance, producing heat. Electrical resistance is greatest at the faying surface, where the pieces of metal meet, so that is where the most heat is generally produced. This is where the weld nugget forms. To make a good weld, it is imperative that the right amount of heat be produced. If there is too much heat, the metal will melt and eject from the joint, producing a flash. If there is not enough heat, the weld will be undersized or will not form at all, and this is what we call a cold weld. In order to regulate weld heat, there are three variables that can be manipulated: current, time, and squeeze force. Current is measured in amperes. Changing this value will have a profound effect on the amount of heat in a weld. Time in resistant spot welding is expressed in cycles. Cycles are units based on the frequency of alternating current. In North America, current is provided at 60 cycles per second, so 6 cycles is equal to 1/10 of a second. There are 3 time intervals which are essential to resistant spot welding. Squeeze time, the time interval during which the electrode tips close and press the material together to create a positive contact between the top piece and the bottom piece. Weld time, the time during which the electrical current is actually flowing through the closed electrode tips. And hold time, the time during which the electrode tips remain closed after the weld current has ceased, allowing the weld nugget to cool and solidify. Adjusting the weld time gives us much finer control over the amount of weld heat than does adjusting the current. Squeeze force in resistant spot welding works differently than you might expect. By increasing the force, you are bringing the surfaces of the parts into closer contact. This reduces the resistance level in the metal stack and causes less weld heat to be produced. In the opposite situation, reducing squeeze force increases the tiny separation between the parts to be welded. This increases resistance and results in more weld heat. In an extreme case of low force, resistance might actually be greater between the electrode and the part than between the parts being welded. This must be avoided because it can result in more heat being generated at the electrode tip than at the material faying surface. This could cause a surface expulsion, in which molten metal can be thrown off in any direction.